This is going to be a boring PowerPoint presentation of the history of the atom. Just kidding! Hello everybody! Today we're going to be talking about the history of the atom. Our adventure starts in 450 to 380 BC, taking us into the lives of philosophers Aristotle and Democritus.
No, you dimwit, there's no such thing as an atom, or whatever you call it. What kind of self-respecting philosopher believes in such nonsense? Everybody knows the building blocks of Earth are the elements.
Please, Aristotle, just listen to what I have to say. There's evidence that points to atoms being the invisible microscopic units of matter, and this is what our world is made of. Surely, you cannot believe that earth, fire, and water are true sources.
There is no way that these small invisible things actually exist. I believe in what I can see, and that is how I will teach my students and followers. I will not teach your way of these non-existent small particles.
But Aristotle!
No buts! I do not believe you, and that is that. Have fun trying to get your theory to pass over with other philosophers.
And there we go! Aristotle and Democritus fighting once again. Is the atom real? Is it not? Maybe we'll never know. Stay tuned to find out.
1800s John Dalton's atomic theory. The main points of this theory include everything is composed of atoms that cannot be destroyed. All atoms of an element are identical. The atoms of different elements vary in size and mass. Compounds are produced through different whole number combinations of atoms. A chemical reaction results in the rearrangement of atoms in the reactant and product compounds. The atomic theory has been revised over the years and consists of isotopes and inconversion of mass. In addition, atoms can be divided into smaller parts.
The solid sphere model was the first atomic model built in 1803 by John Dalton. He hypothesized that it was a solid sphere and it cannot be split into smaller particles. This relates to a baseball because, as you can see, it is very solid and sphere-like.
Hello, today I'm here with Eugene Gould to gain more inside information on the Canal rays and his journey of discovering the positively charged rays.
Hello.
Hello. Can you let the listeners know how you contributed greatly to the study of cathode rays?
Well, in 1876, I showed that these rays could start sharp shadows, and that they were emitted perpendicular to the cathode surface with energy. This discovery led to the design of concave cathodes to produce focused rays, which became fundamental to numerous experiments.
Interesting. Now, tell me a little bit about the term Canal-Strahlen.
You see, I came about the term Canal-Strahlen in 1886, which is also known as positive rays. These rays are positively charged ions that are accelerating towards and through a perovskated cathode in an evacuated tube. I saw something that amazed me. These canal rays were moving through the holes in the opposite direction than the cathode rays. The only explanation would be that they had to have different and opposite charges.
Thank you so much.
You are so welcome.
Alright, in this scene, we'll be further discussing our current project of how the electron came to be. So Joseph John Thompson, or JJ as we call him, was an English physicist who dedicated much of his time and money into the arts of science. In 1897, he performed a series of experiments designed to study the nature of electric discharge, and in doing so, he discovered the electron.
The thing that JJ is best known for would be the cathode tube experiment. In this experiment, Thompson discovered the existence of electrons. He did this using a cathode ray tube, which is a vacuum-sealed tube with a cathode and anode on one end, which created a beam of electrons traveling towards the other end of the tube. The tight, high-speed beam of the electrons flies through the vacuum in the test tube and hits the flat screen on the other end of the tube, like this.
This being said, we end our little discussion with the fact that if Thompson had never experimented with the tube and discovered electrons, that he never would have found out that the cathode rays were negatively charged.
The plum pudding model is a model of atomic structure proposed by J.J. Thomson in 1904. The idea being that we have an overall atom, usually pictured as a sphere rather than 2D, but embedded within it are negative electrons, represented by these small chocolate chips.
The overall atom is neutral, so that means the cookie part must be positive. And that, my friends, is a plum pudding model in cookie form.
Hello, we are back with another game of Jeopardy. We have Anna and Haley, and this is going to be over the life of Robert Millikan.
On
I'm thinking other contributions for 200.
What did he do in 1909?
It was for sure the oil drop experiment.
You betcha.
Can I have oil drop experiment 200?
Who helped him in this experiment?
I'm going to say Harvey Fletcher.
Yep, correct. 200 points.
Let's go. Oil drop experiment for 100.
Ooh, this is a toughie. What is this a picture of?
This? Oh, for sure the oil drop experiment.
You betcha.
Ahaha.
I'll take oil drop experiment 300.
What the second chamber consists of?
I'm going to say electrically charged plates.
You betcha.
Other contributions for 100. We're gonna play it safe.
What did he do in 1921?
It's a toughie. Didn't he die?
Nope.
What's the answer?
Oh, he discovered cosmic rays.
Oh, silly me.
I'm going to take oil drop experiment for 400.
Explain the oil drop experiment.
The oil drop experiment was a fine spray of oil settling on electrically charged plates. The charges that were produced by the X-rays attaching to one droplet. They produced one or more charges on droplets. If there was no voltage, the fall was determined by the mass and velocity. If there was a negative charge, they would fall slow, or there was no fall at all, or they would even rise.
She's really good. The moment you've all been waiting for. The winner is Haley! Woo!
Gosh freaking darn it!
Ernest Rutherford was a British physicist who came to be known as the father of physics.
Hello, I'm Ernest.
Rutherford had many different experiments, but one of the ones that he is best known for was the gold foil experiment. In this experiment, he shot multiple particles at a thin sheet of gold. It was found that a small percentage of the particles were deflected while a majority passed through the sheet.
Some particles go through the sheet of gold. Some particles deflect off the sheet of gold. The conclusion of this experiment was that the mass of an atom was concentrated at its center.
And thank you for listening. In Rutherford's nuclear atom model, the protons and neutrons, which comprise nearly all of the mass of the atom, are located in the nucleus at the center of the atom. The electrons are distributed around the nucleus and occupy most of the volume of the atom. This demonstration was used with a peach.
Niels Bohr came up with a theory that stated electrons do not spiral into the nucleus, and created two rules for what really does happen and how the atoms operate. He knew that any charged particle that is moving is giving off electric radiation. As this is happening, it begins to lose some energy and the wavelength can vary, creating a spectrum. The first rule he came up with was electrons can only orbit in a certain allowed distance from the nucleus. The second rule was atoms radiate energy when an electron jumps from a higher energy orbit to a lower energy orbit. Also, an atom absorbs energy when electrons get boosted from a low energy orbit to a high energy orbit. The Bohr Model explains that if an electron is moving up, it absorbs energy and gains a photon. If it is moving down, it emits photons, losing energy. It also shows that electrons are almost jumping between orbits rather than just moving back and forth, like it was previously believed to.
Hello everyone and welcome back to your favorite trivia game, the phone buzzer game. Today we are going to be doing trivia over Louis de Broglie in 1924, the theories of electron waves. Our two contestants, Haley and Maya. How you guys feeling?
Good!
Alright, let's play some ball! Alright, contestants, what did he discover in 1924? Haley! And your answer is?
The theory of electron waves.
Ding, 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 ding. That is right. Correct. You get a point. Next question. What idea did he introduce? Maya! And your answer is?
Electrons should be described not only as particles, but also as waves.
Oh yeah! Point for Maya! Next question. How many papers did he write on electrons, atomic structure, and X-rays in 1924? Haley! And your answer is?
24, I think.
And you're right again. For our next question. Experiments had indicated that the electron must move around what? Oh, that was close, but I'm going to give it to Maya. And your answer is?
It has to be a nucleus.
Yes!
For our next question, and this one's a biggie. A wave confined within boundaries imposed by the nuclear charge would be restricted by what? Maya. Your answer is?
A nucleus.
Ooh, I'm sorry, that is incorrect. Answered too soon, you were too sure of yourself. Haley, chance to steal?
I believe it's shape because any wave shape did not fit within the atomic boundaries, and that would interfere with itself and be canceled out.
Yeah, you got it right! And with the steal, Haley takes it for the team. Congratulations, Haley. Thanks for playing! Alright, so today we're going to be drawing an electron cloud model. So the electron cloud model, has to start with a nucleus because everything needs a body. So in this model, defined by Aaron Schrodner, the electron travels very quickly within the defined space, creating a cloud of negative charge. So the nucleus starts out here in the middle, and then electrons are all close to them here in the middle, clustered together. But as it grows farther out, it spreads, creating more of a cloud shape. The electron cloud model is defined as the area around the nucleus of an atom where electrons are most likely to be found.
1932. James Chadwick's discovery of the neutron. Here's how I'm thinking it went down. James was working in his lab all day and came across a wonderful discovery: neutrons. He took atoms from lithium and shot alpha particles and noticed rays getting released from the atoms of lithium. He knows it doesn't have a charge, but he still doesn't exactly know what they are. Him and his other scientists decide to put wax in front of the rays. They discover that protons shoot out. Then they figure out that the rays coming out both have to be the same size and mass. That brings them to the conclusion that neutrons are being shot out of the lithium. Well done, James.
Alright, and that concludes our video today. Hopefully all of you feel super educated about our journey of the atom and electrons and all of that fun stuff.
Thank you.
Thanks for watching.